Fibonacci sequence. So, as we have seen in the previous section, the human mind is attracted and can easily recognize patterns. For example, patterns we see in nature, we have symmetry, cracks, fractures, tessellations, and many more. In mathematics, we can generate patterns by performing one or several method or mathematical operations repeatedly. Another beautiful pattern manifested in the world is the Fibonacci sequence. These patterns appear everywhere in nature. For example, flowers, from the bracts of pine cones, the scale of pineapple, or the seed heads of the sunflower. So the Fibonacci sequence is the series of numbers 0, then we add 1. 0 plus 1, 1. 1 plus 1, 2. 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 13. 13 plus 8, 21. 21 plus 13, 34, and so on. So the next number is found by adding up the two numbers before it. So the number 2 is found by adding the two numbers before it. So how do we get 2 here? We get 2 by adding the two previous numbers, which is 1 and 1. How do we get 3? We add the two previous numbers, which is 1 and 2. How do we get 5? We get 5 by adding 2 and 3, and so on. So from this, we make certain squares. So we have, for example, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, 21 plus 13, we have 34. So we can see this, the beauty of this, we call this one the golden spiral, having this video. The Fibonacci sequence is composed of 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34, 21 plus 34 is 55, and so on. So you get the next number by adding the two previous numbers, and then you will create the Fibonacci sequence. I hope you enjoyed the video. So the Fibonacci sequence again is created when we add the two previous numbers. And from the video, we have 1 plus 1, we get 2. Then 2 plus 1, 3. 3 plus 2, 5. 5 plus 3, 8. And we create a spiral. So we call this spiral as the golden spiral. And from the golden spiral, we see from the video the distribution of seed heads of the sunflower. Okay, so the Fibonacci sequence or the Fibonacci spiral can be easily spotted in the pine cones, seashells, sunflowers, flower petals, just like we discussed a while ago, from one petal flower to two petals, three petals, and countless other forms. So nature exhibits patterns, sometimes in numerical pattern like the Fibonacci sequence. George Zavorsky highlighted that the famous Fibonacci sequence has captivated mathematicians, artists, designers, and scientists for centuries. So the person who discovered the Fibonacci sequence is Leonardo Fibonacci. So Leonardo Fibonacci came up with the sequence when calculating the ideal expansion pairs of rabbits over the course of 1 year. Today, its emergence patterns and ratios called phi is 1.61803 up to infinity. Can be seen from the microscale to the macroscale. The Fibonacci sequence is one of the most famous formulas in mathematics. It's been called the nature's secret code and the nature's universal rule. So mathematicians, scientists, and naturalists have known about the golden ratio for centuries. The golden ratio derived from the Fibonacci sequence. It describes predictable patterns on everything from atoms to huge stars in the sky. Nature uses this ratio to obtain or maintain balance, even in the financial markets like stock markets as well. So here are some of the examples of patterns involving Fibonacci sequence. Number one, the seed heads, distribution of seed heads in the sunflower. So the head of the flower is also a subject to Fibonaccian process. Sunflowers have a spiral seed arrangement. This provides a biological advantage because ang purpose ani niya nagamit siya Fibonacci sequence ang kaning sunflower is to maximize the number of seeds that can be packed into a seed head. In order to optimize the filling, it is necessary to choose the most irrational number there is, and that is, we call that one the approximated by a fraction, or we call that one the golden ratio. This one, the 1.61803. So, ang pag-distribute sa seed head, follow silang pattern nga 1.618.03 ang angle. Next, makakita sa Fibonacci sequence in the pine cones. So, we have here, just like the seed heads and distribution sa seed heads, pa counterclockwise 21, pa clockwise 34. And take note, 21 and 34 are two numbers in Fibonacci sequence. In pine cones, we also have, let's say, 8 pa clockwise and 13 pa counterclockwise. Take note, 8 and 13 are also found in the Fibonacci sequence. Next, the tree branches and roots. So this one, we have 1 ka-branch plus 1 ka-branch na ay 2. Then 2 plus 1 ka-branch na ay 3. Then 3 plus 2 ka-branch na ay 1, 2, 3, 4, 5. And 5 plus 3 ka-branch na ay 8. Yang 8 plus 5 ka-branch na ay 13, and so on. So, ingani ang pag-grow sa ato ang trees. From trees, pine cones, seed heads, and even the roots of plants and trees, ni-follow na sila o Fibonacci sequence. Also, ang pag-form sa shell and the spiral galaxies and the number of petals in the flower. So, let's start with shells. The unique properties of the golden rectangle provide another example. This shape, this one, this is the golden rectangle, kaning white, kaning nag-form og mga rectangle or square. This is the golden rectangle niya. Kaning yellow, ang curve mo ni siya, gitawag na to golden spiral. Niya, ang katong 1.618 mo to siya golden ratio. So this shape, a rectangle in which the ratio of sides A and B is equal to the golden mean. Pila get the golden mean? We have the 1.618, can result in a nesting process that can be repeated into infinity, just like what we see in the video a while ago. So snail shells, nautilus shells, cochlea in the inner ear follow this golden spiral. Okay, as well as the horns of some goats and the shape of certain spider webs. We can also see the Fibonacci sequence in our spiral galaxies and even the hurricanes. We can also the Fibonacci sequence in the petal counts or the petal counts of a flower. So just like what we did a while ago. Flower petals always follow the sequence. For example, the lily has 3 petals, buttercups have 5. Okay? And just like we have a while ago, the anthurium, we have 1. We have bougainvillea, we have the euphoria, daisies. So we have seen in the preceding sections how evident mathematics is in the natural world. This means that the world is full of patterns. The world is full of numbers. So therefore, to understand the world, we will use mathematics. Specifically in how the patterns we observe in nature follow logical and mathematical structures. As Ian Stewart said, we live in a universe of patterns.